Welcome to Microwave Engineering lecture series. In this lecture series, I'll discuss about this microwave transmission lines. So there are three types of microwave transmission line. One is two parallel wire transmission line, coaxial transmission line, and microstrip transmission line. So here we'll discuss about this two wire transmission line. This is the cross section of two wire transmission line. This two wire transmission line was used in the earlier application in the earlier years of 2000 for like telephone cable application. We can see that is actually of two wire parallel wire transmission line cable. And here now we'll see this cross section of this two wire transmission line. You can see this this two wire transmission line which is separated with the dielectric material, and it's a cross section of this two wire line. This is of conductor 1 and this is of conductor 2. This conductor will be of this positive and this will be of this negative. So when this conductor with the fields which is emerging out of this conductor, which is this D is a distance between the conductor. Capital D is the distance between this conductor, and for this area of cross sectional we say it is of del L. This area of cross sectional, we will take this cross sectional area for analysis purpose, so that we say as an del L, that is the L is the length of this transmission line. And here if we see, this is a positive conductor, that is electric fields which is emerging out of this conductor, that is of which is emerging out of this conductor, and here it will form the closed loop between these two conductors. This is a two conductor, so when this is the positive positive conductor, and here we can see it is of negative, and the fields which is emerging out from this conductor to this conductor, so the electric field will be flowing in this direction, that is of vertical direction. So according to this right hand thumb rule, so the current be in the it will flow in the horizontal direction, that is of magnetic field will be the opposite to the electric field. So here this is the out of phase current is flowing in the out of phase, and here the current will be in the form of in phase. This is the electric field fields, and this is the magnetic field which is accompanied with the closed, it is formed in a closed loop condition. And here characteristics of two wire transmission line. Before going to this, we have to see this inductance and capacitance of this transmission line. This inductance and capacitance of this transmission line is calculated with this distance between this conductor and this radius of this conductor and the differential length. Based on this we calculate the inductance and capacitance of this wire. So here I have noted as an L dash, that is nothing but this of L, that is this thing L, and this is the circuit distributed circuit diagram of this transmission line. This is a basic transmission line diagram, and this basic transmission line will be the same transmission line model from this distributed model for all the string for coaxial cable and this thing. This is a basic model here, and here this cross section of transmission line calculated using this the basic fundament of R in resistance and inductance, and this is which is carried out with the capacitance and conductance, that is of this we call as a tank circuit. And this inductance and capacitance is calculated with this formula of inductance is calculated with the mu naught by pi ln of 2 d by d. That d is capital T is nothing but the distance between this conductor, and small t is the radius of this conductor. And next the capacitance. So this capacitance formula is pi epsilon divided by ln of 2 d by d, similar to this whatever I had discussed this previously. This d and d, capital T is the distance and the small t is the radius of this conductor, and mu naught is then permeability, and epsilon is the permittivity of this conductor. And here based on this we calculate the characteristics impedance. This characteristics impedance is calculated with this R plus J omega L divided by G plus J omega C. And we know this for any lossless transmission line, that inductance and conductor that is resistance and conductance will become 0. So if we apply 0 to this here R0 and G0, so this will become 0, and here that is, so we'll get only the parameter of j omega L divided by j omega c. So this j omega will get cancelled. That is, so the z naught will be of root of L by c. For any transmission that is of lossless transmission cable, that characteristic impedance will be z naught is equal to root of L by c. In next, we'll discuss about this coaxial transmission line